Hello and welcome to Chapter 9, Section 7. Today we're solving quadratic equations by using square roots. So just a quick refresher, a square root is a number multiplied by itself to get the original number, and this number can be positive or negative, and we forget this a lot. So this is where we really have to remember it. So the square root of 9 is 3, or it's negative 3 because 3 squared is 9 and negative 3 squared is 9. So when we write that the square root of 9 equals plus or minus 3 so that we remember those positives and negatives. And when we're working with quadratics, we have a property of square roots. To solve x squared equals a, you're going to take the square root of both sides, and that looks like that. So you know that when you're solving for x and x squared is a, then x equals the square root of a. What I also want you to remember is if you're looking for the square root of x squared, it's always x. This is just one of those, it's like 1 equals 1 and 0 equals 0. One of those stupid properties that don't really make a lot of sense. Why do we have to learn those? But it's a good thing to remember that one because that's actually useful. So they ask us to try a couple, and they're stupid, and so it's easy. When x squared equals 16, x equals plus or minus 4, and we know how to do that. And when x squared equals negative 4, we know that x equals the square root of negative 4, which is actually an imaginary number. So right now our answer is no real solution. Now, side note, it's actually imaginary. And it is written lowercase I. So the square root of negative 4 is actually 2i, because I is half of a square root. Square root of negative 1 equals I. So the square root of negative 4 is the square root of negative 1 times the square root of 4. Which is 2 times I, 2i. So you're going to start using this in trigonometry and algebra 2. It actually is called an imaginary number. It's written with a small I, and it's always curvy like that, so you don't mess it up with anything else. But yes, future world. But for now, the answer is no real solution. So what I'd like you to do is take the whole 30 seconds it's going to take you to get through checkpoint 1 questions on the top of page 657. Pause here and come back. So 1a is plus or minus 11, and 1b is 0, and 1c, because that's a negative number, is no real solutions. If you have any questions, let me know. Then we're going to take it to the next level, and we're actually going to add some numbers to it. X squared plus 5 equals 5, which means x squared equals, and I'm going to subtract 5 from both sides, and there my x squared equals 0, which means x equals the square root of 0, which is 0. Here, I notice that this is a perfect square, and this is a perfect square. So in order to find x, the first thing I'm going to do is I'm going to get rid of that squared. So now I know that x plus 2 equals 3, plus or minus 3. Now I have to solve the plus version and the minus version. So I'm going to say x plus 2 equals 3, and x plus 2 equals negative 3. And when I subtract 2 from everything, I end up with x equals 3 minus 2 is 1, or x equals negative 5. Got it? Let's try this one. 4x squared minus 25 equals 0. Well, that means 4x squared equals 25. And we can find the square root of that and the square root of that. And this is 2x equals plus or minus 5. So x equals plus or minus 5 over 2. There's another way that you can solve this. 4x squared equals 25. x squared equals 25 over 4. Because both of these are squares, you could also do it that way and say x equals the square root of 25 is 5 over the square root of 4 is 2. And it's a plus or minus because it's a square root. We got to the same place. Either we took the square root on this side, or we divided by that and took the square root on this side. So it really is whatever you see. The book saw it this way, I saw it this way. Both of us got the same place. Okay? Pause here and try check it out, number 2 on the bottom of page 257, and come back when you're done. Check it out, number 2. We subtracted 49 from both sides, and that gives us no real solution because this answer is a negative number. We know that we can't actually find the square root of it, so the answer is no real solutions. Here, the square root of this is x plus 5, square root of this is plus or minus 4, so we're going to have to solve for both of these. X plus 5 equals 4 and equals negative 4, and we subtract 5 from everything, and we get that x equals negative 1 or negative 9. What happens when you're trying to solve for x and you're using square roots and your square root is not the perfect number? It's not a 49 or a 100 or a 25. So our example here, 0 equals negative 2x plus squared plus 80. I always like my my a to be positive. So we're going to add 2x to both sides. So I've got 2x squared equals 80. I'm going to divide both sides by 2, so x squared equals 40. And I want to find x, so I'm going to find the square root of both sides. Well, 40 isn't a perfect square. So I'm actually going to put that into my calculator. I'm going to say, what's the square root of 40? And it's going to give me a big long number. And I'm going to look at the thousandths place, and I am going to round my hundredths up or stay the same. So don't just take the first 2 digits after that decimal. Make sure you're rounding to the nearest hundred, okay? Try check it out, number 3. Pause here and come back when you're done. Check it out, number 3. We're going to subtract x squared from both sides, and we're going to find that the square root of 90 is plus or minus 9.49 because we rounded. We're going to add 64 to both sides and then divide by 2, and the square root of 32 is plus or minus 5.66. And C, we're going to subtract 45 from both sides, and we realize that because it's negative, there's no solution. All right? So the word problem in example 4 is all about an isosceles right triangle. This is a pen at a zoo where we don't know the length of each of the sides. Nor do we know the length of the hypotenuse. However, we do know that the area is 4,500 square feet. So we have to backtrack to say 4,500 equals 1/2 times base times height, which is the same because it's isosceles. So we've got 2x's times 1/2 is going to equal 4,500. So we have to work backwards. So if I multiply both sides by 2, I get 9,000 equals x squared. And I want to know what the square root of 9,000 is. So x equals, and the square root of a calculator is not plus or minus because this is an actual thing. It can't be negative feet. So it's going to be a positive 94.9. And we're going to round up. It says to round to the nearest whole number, so it's going to be 95 feet because we solved for x. There's another perimeter area problem in check it out number 4. So please pause here. Realize you're going to use the area that you know is equal to 1/2 times, and they give you the height, and they give you base 1, and they give you base 2, and you're going to need to figure out, using this number, solving for x. Pause here, give it a shot, come back when you're done. So we know that 6,000 is equal to 1/2 the height times both the bases, and that the height is 2x. So 2x plus x is 3x, and the height is 2x, and we're essentially dividing it by 2 when we multiply it by half. So it's 2x times 3x divided by 2. And 2x times 3x is 6x squared times 1/2 divided by 2, which is 3x squared. So 3x squared equals 6,000. And when I divide both by 3, I get x squared equals 2,000. So our mathematical answer is plus or minus 44.42 feet, but they want it in positive, rounded to the nearest foot numbers. So our answer is going to be 45 feet. This gets a little complicated, but it's not hard. It's keeping track of, I know that base 1 is 2x. I know that base 2 is x. I know that h is 2x. And I have to solve for x. So I have to keep taking it step by step. And that can get complicated, and you've really got to keep track of your pluses versus your times, and how many x's do you have, and what you're doing where, and all that jazz. So take a deep breath, it's going to be okay, but that's what algebra is for, is to help you problem solve, remembering all of your details. That's what part of your brain we're developing right now. So your homework tonight starts on page 659. It's numbers 17 through 35 plus 43. So make sure you ask me any questions, and I will see you tomorrow. Good luck. Take care.